Greetings and welcome back to the lab, and welcome to Freeform Friday. And if my voice sounds a little funny, it's because I'm getting over COVID. Enough of that, though. Wanted to try a quick experiment, this being Thanksgiving week. I don't want to do really long videos, but there's something I've been wondering about. I've got these RGB LEDs, but the thing I didn't like about them, and I'm going to put up a warning here that it's going to be flashing colors here. There should be actually one right at the beginning of the video. So here they come, but this will give you an idea. So it starts out slow, and then it picks up speed. Then it goes back to slow. Now, I haven't really liked these for any other project, but it occurred to me that these might be useful as sort of twinkling lights for the Christmas display, for the DIY Christmas lights. So I've ordered up some new C9 shaped bulb circuit boards that actually have 4 more LEDs on them, and it's rearranged a little bit, and it's actually set up to meet the interface that the DIY bulbs are set up for. So what I want to do is I want to put a resistor in here, a single resistor. I've done some calculations and figured some things out. Let me kind of blow through that really quickly for those that are interested. That bulb, I have a video. I took a video of the bulb with my voltmeter, and maybe I'll put a little piece of it up here. But just so you can see, I slowed it down so I could see, and ultimately at its low point, it was consuming 2.5 volts. At the high point, it was 4.5 volts. So the average is going to be 3.5. And I was looking at my resistors and trying to decide. Ultimately, I think I'm going to go with a 430 ohm resistor because I happen to have an extra package of those that I got with some LEDs. And I don't know if that's going to be the perfect solution for it. So the other possibility, if that doesn't look right, is I found my resistance substitution box, which it has little dials, and I can change the resistance and see how it looks. So that's another possibility. So I'm going to put that in loosely, and then I'm going to start populating it with LEDs, and I'll basically come back when I'm ready to go to test it out. Oh, I forgot. Cue the music. Alright, well, that didn't take too long, but as it turns out, I'm running low on connectors, so these are some automotive connectors I happen to have, and I wired up another 12-volt power supply, and let's just see if this thing functions, and I'll put the warning back up again. If you're visually sensitive to blinking lights, that's what you're about to see. So here we go. 3, 2, 1... give or take, and nothing happens. Okay, something's wrong. Let's figure that out. Hey, am I plugged in? Yes, I am plugged in. I should have output here. Let me double check that I've got this connected in the right polarity. Should be positive and negative there, right? Yeah, that seems to be the right polarity. I cannot reverse the polarity. It made an interesting sound. Alright, I'm going to see if I can figure out what's wrong, then I'll come back. Cue the music again. Okay, I found it. It turns out it's this one right here, and I put it in backwards. So, I'll fix that. Back to the music. Alright, moment of truth. Let's see if this works. I did notice when I found that one backwards and I tested it with the battery that one was also lighting up. So it may be that one's in backwards too. Let's find out if this works. Nope. Alright, back to the music. Alright, I said this was supposed to be a quick video, and I also said I'm recovering, so I'm going to call it quits here, maybe pick it up tomorrow, and hopefully get a video out by Friday. Actually, it just occurred to me what the problem may be, and so I'm not going to give up that quickly, and this may be a rather simple fix, and it goes back to what I did with the previous one, where I only populated three of the four. Let me draw this out a little bit. We basically got LED, 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 LED. They're in series. And if you add up four of these in series, even at the 3.5 average, you end up with 14 volts. And if it should happen to be the 4.5 average, you end up at 18 volts. So if you're lucky and it's 2.5, then you're looking at 10 volts. So I think that's the problem. I think that even though it tends to start on red, most of these color-changing LEDs tend to start on red. I think the problem is it's not even starting up because it doesn't have enough voltage to get going. So once they get out of sync, it would hopefully work okay. So what I'm going to do is I'm going to remove this last LED. I'm going to replace it with just a jumper across it, so that basically I'll be ranging between 7.5 volts. I'll leave this to you for the math. And let's see, 4.5 times 3 is going to actually be 13.5 volts. That's still too high. That's interesting. But let's give that a try. Let's see if it can pump out just enough voltage to get it started, and then after everything goes out of sync, then some of the strings may turn off because they don't have enough voltage. Let's just see what happens. So, once again, back to the music. Well, let's see if taking out one LED from each string will do the trick. Oh, that's anticlimactic. Come on, go in there. Not enough. So my resistor is perhaps a little too big now. It's not heating up or anything. But I did confirm earlier that I had 12 volts making it in here, so I know it's not the connector. The only thing left is it must be starting at a different color than red. So, Alright, well, I guess we'll leave this as a mystery, and it'll be something we can pick up on another Freeform Friday. Or if I figure it out independently, off camera, then I'll include it in the next episode. Or I could just come right back now, and did you think I was going to give up that easily? I did figure it out. It turned out it was actually the connector. I guess it wasn't fully seating, but once I got a different set of connectors on there, I got it working, and I'm going to show it to you, but I'll put up the warning right now. It is working, so we've got flashing lights. It's been running all night. So here we are. Hopefully there won't be a big avalanche as I pull this out. And we have our sort of twinkly light kind of thing, and I think that is kind of Christmassy. I think I can do this on the boards that are on their way. And let me disconnect it now. So for the people with photosensitivity, they can see the... Okay, you can look back now. And so these are, I believe they're called JST connectors. They're really designed for like remote control cars and stuff. They're incredibly lightweight, and they're really designed so you could like power the headlights on a remote control car or something like that, where just a couple of LEDs, you're not drawing a whole lot of power. So the irony is that this particular power supply that I put together has actually has a 2 amp limit. I'm not going to be pushing that much through here. This is really just for a test supply on the bench, or a bench power supply, sort of. Not the same thing, really, but for 12 volt tests. I've been doing a lot of 5 volt, now I'm getting into 12 volt, so here we are. I think it does kind of work. I'm happy to have this up and running again, or up and running, period. So, thank you for sticking through it with me. I hope you have a wonderful Thanksgiving. Or I hope, well, actually, I guess if this is going up on Friday, I hope you had a wonderful Thanksgiving. Take care of your friends, take care of your family. Take care of yourself. We'll see you on the next one.